Option number 3. Here we go. Graph number 3. Boom. Now our next page. Okay, we got these two. Okay, done. Now we're on to page 14. It's not numbered. I didn't do that. Okay, so here we go. Yeah, page 14. Next one here. Let's see. Scene. There we go. All right. Parent function. This one also another one we should be a little bit familiar with. We've been working with it so far this year. We've been using it. This is an exponential. Exponential. Okay. We've been calling it expo just for short. Trying to keep life easier on ourselves. Hey, let's frame ourselves. There we go. Oh, we're cutting our head off still. All right. Well, that's fun. Maybe. Okay. There's no happy medium. I don't know. I'm just going to deal with it. Exponential. Y equals... for this one, this is... we'll stick with just our basic here. Y equals 2 to the x power. Okay, we're not going to talk about any of the like extras. This one technically has a few different pair functions, but we're going to stick with the most basic, just 2 to the x power. What else do we got going on here? Let's talk about points. Let's plot points here first. Okay, let's plot points. So if we have x equals 0, y equals 1. Okay, that seems should be pretty straightforward because you put in a 0 power, you get 1. Okay, we can test that on the calculator another day. We'll test that out. But if we plug in 1, that would be 2 to the 1 power, which would be just 2. Okay, so it'd be 2. We also have that point right here. Okay, and then also, if we go up to 2, we go up to here, x equals 2. X equals 2, then that's 2 to the second power, which would be 4. Okay, so 2 to the second power, 2 squared would be 4. So exponential, they get big really fast. They get big super fast. It's just like this. It gets big super fast. Okay, again, we should be putting arrows on here because these functions continue. They can, they're not like ending. Okay, we're continuing. Man, I just made my desk vibrate. Okay, there we go. But what happens when x gets smaller? That's the question. Okay, what happens when x gets smaller? It's easy to see what happens when x gets bigger, right? We just get bigger and bigger and bigger. But there's more to it. If we continue backwards, like right here, okay, x equals -1, what happens is this. We get a power of -1, which means that we actually end up at 1/2. So it's like we get like really close to 0, right? It's like we just like cut our distance in half from how close we were to 0. Like we were like 1 unit away. Now we're halfway. What happens when we go to -2 for x is that distance gets cut in half again. So now it's 1/4. Okay. If I was so inclined and I kept going, which I'm going to do, you guys know me, and looked at x equals -3, what happens is this. That distance, now that it's 1/4, that distance gets cut in half again. Now it's 1/8. And if we kept going, it would keep going. It would just keep getting cut in half. 1/16. Then it would be 1/32. Then it would be 1/64. It'd be even closer and closer and closer and closer to 0. But think about this, guys. If I cut something in half, if I cut something in half, I had these 2 markers, and I cut them in half. What happens? I cut them in half. Now, these 2 markers are 1 length. I cut them in half. Okay? There you go. Half of it's gone. All right, that's great. Half of it's gone. Okay, I've got this half left. Let's pretend like the cap is the other half, too. So I cut it in half again. Okay, it's getting smaller. It's getting really smaller a lot, like really fast, actually, right? If we keep cutting this in half, and then that's in half, it would keep getting smaller and smaller. But would it ever get to 0, though? If you keep cutting something in half, does it ever reach 0? That's the question. And I'll answer it for you. It doesn't. It really doesn't, okay? So what happens is this. This is our first one that has this fancy thing called an asymptote. And we'll draw that in there too. Okay, so what happens with this graph is we've got this asymptote at y equals 0. It doesn't cross that line. That is a boundary. That asymptote is like a wall. The function can't cross it. Okay, it'll get really, 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 really close, but it'll never actually cross it. It'll never actually touch it. So this is our first example of having an asymptote. So there we go. I wrote that in. Domain, we got all real numbers. Okay, it's similar to others. Or we were calling that -infinity to infinity. Okay, our range with this one, it's really similar. It's really similar to the quadratic. Okay, it's really similar to quadratic. It's going to be 0 is my lowest, but see, it doesn't actually touch 0. It just gets really close to it. So it's kind of like those open dots we had from Friday. Okay, kind of like those open dots we had from Friday. Instead of being less than or equal to, where we're going to include 0, we're going to exclude 0. We're going to say, hey, 0, you're not a part of this. But if you're bigger than 0, then you are. So any y bigger than 0, boom, we're good. Got it, okay? What this looks like in interval notation, it's a subtle difference. Instead of being that like fancy bracket that I've been using, it's a parentheses. And again, these are the small details that we can get into later and that we can focus on later. Right now, let's just say, hey, it's 0 is my smallest, and then we're going to go all the way up to infinity, okay? So that's what interval notation would look like with that one. Again, interval notation, we'll get there later. Don't worry. But we're getting into our notes. X-intercept, there is none. There is none with this one, okay? There's no x-intercept. It doesn't cross the x-axis, okay? Whereas y-intercept, though, it's at 0, 1. Okay, that one's at 0, 1. All right. Max min, there is none. No max min. Not for this one. Okay, so there we go. Actually, that brings up a good point. Totally forgot to do this on the last one. So, hey, let's flip the page back over to the other one, because I forgot to address a couple things. And I'm sure that you guys, if you've gone to this video before, you're probably like, Coach, you're missing stuff, as usual. There's no asymptotes for quadratic functions, and there actually is a minimum for quadratic functions, and it's at 0, 0. Okay, see how that's a lowest point right there? Okay, it's a lowest point. It kind of like goes up to it and then turns back around. That's the lowest point, so that valley. Okay, there's that little valley here, that bottom of the valley, that's going to be our minimum point. Okay, that point was 0, 0. Whoops.